From the complexities of blood-based tests to the challenge of determining the most relevant proteins, Dr. Isaacson breaks down how biomarkers are shaping the future of neurodegenerative disease detection and prevention. Let's dive in.
I think amyloid and tau are a big part of the story, and I would say even a really important part of the story. But amyloid's confusing. 2 out of 3 brains that are affected by Alzheimer's disease when a person passes away. So when you look at autopsies, so you look at the brain of a person who's passed and you look at the brain and there's amyloid everywhere. 2 out of 3 of those people had dementia, but 1 out of 3 did not. And why is that? So to me, amyloid is a marker, a biomarker of increased risk, but it's not a definitive marker that a person is going to develop Alzheimer's disease dementia. I think that's really important. I think looking at a panel of markers is really the way forward. The combination, for example, of having some amyloid, but also some tau, p-tau 217, there's also p-tau 181, p-tau 231, as well as other markers, some really exciting markers. Actually, today we literally saw on our spreadsheet, wait, what is this one? I've never seen this one before. Why is that high in all of our patients that we're worried about? We better look into this marker. And again, we're trying to bring costs down and increase access. So how do we bring costs down? We want to figure out which of these 120 markers that we're looking at are the bare minimum. And if we can find 5 and do that as a panel and, run them on a plate and, again, to bring down costs, if we can find 5 and put that into some sort of a predictive measurement, that is really critical. So we're in, I would say, two paths. One is discovery neuroscience mode, where we're looking for new biomarkers at this time. And the good news is we have the gold standard, which is either blood tests for amyloid and tau, p-tau 217, or spinal taps or PET scans of the brain. So we have what some people call ground truth, which is like the thing you compare it to, the gold standard. And then we can use the amyloid and tau, and then we can use all these other over 100 markers that we're investigating now. And they're like cousins of certain markers, and alpha-synuclein and this synuclein and phosphorylated this. And these are like terms that are confusing, but that's our goal. Our goal is to both use what we have out there that's already been validated, but also validate new markers and put them together in protocols. The challenge that I think most people don't understand is not all blood tests are created equal. And this is something that is really important. I would venture to guess that 99% of people that are watching this don't understand or never heard of that LDL cholesterol, the most common one that everyone gets checked, the vast majority of times, it's an indirect measurement of LDL. In research and in our clinical practice, we measure a direct LDL from a very specific assay, meaning a very specific lab test that was developed by a specific lab. And that's the most accurate. So if you check it from day to day or hour to hour, it's going to be very similar. But a lot of these new tests, amyloid, tau, whatever, they may not be as accurate. And they may vary from hour to hour, from day to day. And that's not okay on our watch. Alzheimer's is not something that we want to play around with. Alzheimer's risk is not something we want to say, oh yeah, your risk may be high, or it is high. Oh wait, we just repeated it. It's not high. That's not okay with Alzheimer's disease. The other aspect here is just relying on one test, like a single test. There's no single test. p-tau 217 is a very good test, but not for what we're looking for. We want to understand the whole gamut. We want to understand the full picture. And we're really close, I think, to having a sense. And I feel like in the next 3, 6, 9, 12 months, the advances are just going to be amazing. Just as a point of reference, 3 or 4 years ago, we were looking at one blood biomarker. 3 years ago, we were looking at 2. 2 years ago, we were looking at 6. And now we're looking at over 120. Reference ranges for these biomarkers are very new. Literally today, we literally spent like hours with spreadsheets of all the people in the research study in the cohort that are control subjects, meaning they don't have symptoms, they don't have a family history, whatever our definition of control. Even their values were a little bit all over the map. So like, what is a normal reference rate? Like an LDL cholesterol above 100 is okay. Oh, that's not as good. Depends on the person. And reference ranges should depend on the person. If a person has a lot of cardiovascular disease history and their family member died at 45 from a heart attack, is 100 or 130 or 160 okay? No, I want the LDL cholesterol 70 or below. Heck, I want it 55 or below. So with brain disease and neurodegenerative diseases, like we're just still trying to figure out what the reference ranges are. Getting each individual person's reference ranges can be informed greatly by a baseline and a change over time. I think the other thing is that some of these biomarkers are complicated. We always get all the brain biomarkers in the morning, ideally between 8:30 and 10 o'clock in the morning. We get them fasting. Water, black coffee, tea is okay. No sugar, no milk, no cream, no exercise that morning. need to have a good night's sleep. And if you're coming from the West Coast, we'll do your blood draw at 10 o'clock Eastern or 10:30 or 11 to make it a little bit more like your normal wake up time. And we do this because when we're in a research phase and we're in a data validation phase, it's really important to standardize. And again, single snapshots in time of certain blood tests may be less reliable, but getting this longitudinal data and standardizing it in a really rigorous way is key. And IND is really trying to not just advance the science, but also advance the education. I think we're still a little bit of ways away from broad scale adoption, but we're really committed to bringing costs down, increasing access, and improving what is the bare minimum we need in science at the lowest possible cost. And how do we scale this in order to make the broadest impact on public health?
We hope you enjoyed this video. To access a free Mastering Brain Health course led by Dr. Richard Isaacson, visit ind.org/learn. And to directly contribute to IND's research efforts, visit ind.org/donate.